Hey y'all, Professor Wyman here yet again. I am just going to show you how to do some analyses in Jamovi. Again, this is just to kind of give you a preview so you can kind of see where I get the numbers that I will give you in class. So I am going to, first of all, I'm going to save because I didn't save after doing, in the previous video, I cleaned the data. Cleaning just means that you make it ready for analysis. And so I'm just saving it. I do want to make a note here that it does give me the order, like this is the bird people, this is the opposite people, but I did kind of a simple example today. I just showed you manually how to set this up. It's more prone to possible error, so we have to be careful about that. But again, I just want to kind of show you for now what the concept is of what we're doing. So I have all this data. I need to do something with it. I'm not going to do any null hypothesis testing or anything right now. I just want to describe some information for you. So I am going to go to, oops, that's not where I'm going. I'm going to go to analyses. And I'm going to go to exploration and descriptives. And we have a variety of different variables here, which is great. So I want to show you some basics first. So when we're here, we have a lot of options for different statistics that we're going to look at. And notice that it automatically checks what it thinks you're going to want. There's also plots here. And so you can see, you can create different plots. I like to look at the graph first. I think it's really helpful to see what the data looks like. But there's kind of some standards that we're going to go by. And so let's start with a continuous variable. I'm going to start with age. I'm going to move age to variables. And you can do that different ways. So I moved it with clicking on it and then doing the arrow. You can also drag and drop. I can move other continuous variables there. So like our total social loafing, it's got that little ruler. That means it's continuous. I could move that over as well. And you know what? Let's go ahead and do it. I'll put social loafing there too. No, I lied. I'm not going to put that there. Just kidding. So let's just do age for now. So I want the mean, the median. That's helpful. Standard deviation is great. Minimum, maximum. I'll leave all that there. For continuous variables, those are the appropriate measures. Now, I have my Jamovi set to, on this top right here, I have it set to 4 decimal places for the number format and for the p-value format. And I do have a reason for that. You can also change it. Yours might automatically be set to maybe like the 3 scientific figures or something like that. The key is that when we do percentages, it's not going to show percentages with 2 numbers after the decimal unless we have it at 4 decimal points. That's why. So when you report this, we'll talk about how you report this in APA, but you're typically going to have 2 numbers after the decimal, or you just want to be consistent. So I'm going to have you do 2 numbers after the decimal. So here you can see that age, the mean is 21.86. The median, though, is not a lot, but about a year lower at 20.50. And our ages range from 18 to 35. So that's a pretty big age range, and there's a pretty big standard deviation there. We're going to talk about what all of these numbers mean, but in this video, I'm going to demonstrate how I get these numbers. Now, for continuous variables, I can do a couple different graphs. So I can do a histogram, and the histogram, you can see that we have a positively skewed distribution. So most students are on the younger side, and then we have a couple people who are older that are kind of pulling our mean up, which is why we're saying it's positively skewed. We have the majority of the scores on the negative side of the distribution, but it's skewing positive. So this is an appropriate graph, this histogram. You can see that the columns are touching. It's created these little bins. So each of these bars is a bin, and it does this automatically. You actually can't change it in Jamovi. It's one of the not great things about it. But you're not usually going to use a graph that you made in Jamovi. You're just using it to kind of understand your distribution. Now I'm going to click out of this because I want to make another graph. I want to make another graph for age that I don't want it to overlap. And so I'm going to go back up here. I'm going to move age back to my variables, but I'm going to unclick all of these. So I don't want any of those this time. I already have that above. I just want to make what's called a density plot. Isn't that pretty? It just looks, it's a little bit cleaner. And so we'll talk about what that density refers to, but it shows you the shape a little bit differently, right? It's a little bit easier to see kind of the shape of the data. You could also do a box plot for continuous data. And so this is a box plot right here. You can see that the middle 50% of ages looks like they range from about maybe 18, 19, 19 to 22. And then this is the other 25% here and the lower 25% here. And then we have some outliers. And this tells us which people they are. So this is participant number 27. Now, since these are your responses, I'm not going to give you the actual data set. So that way you don't have to worry about, somebody knowing your social loafing score or whatever it is. But I'm going to export this so you have access to it. So this is age. This is a continuous variable, age. So now I can do a couple different things here. I'm going to save this. I'm going to save as, and I'm going to say that this is age, and I'm going to save it. And I'm going to give you an export. So I'll go to File and Export. And I'm going to say age. And it's going to export as a PDF. And then I can give this to you. I'm going to print it out for you and give it to you in class. You can write all over it and write notes on it. So this is a continuous variable example. And so we have some different options here for a continuous variable. Now I'm going to reopen my, I'll stay in this data set. I'll show you how you delete these. So now I've got that data. I'm going to share it with you. We'll talk about it in detail in class. But I'm going to take these out. Maybe I'll just change the variable. So anytime, like if I click up here, you can see it goes back to the data. But if I click back on the analysis, it's going to go back to the analysis. So I could change what I'm analyzing. So I could change, instead of looking at age, I could look at gender. Let's look at gender instead. And you can see that it gives us a mean and a standard. It's like, oh wait, no, we don't want that. This is actually a nominal variable. Gender is nominal, it's just categories. I do not want a mean or a median. And I'm actually going to uncheck all of this. That is not useful information for me. I want a frequency table. That makes more sense, right? Getting a mean, like, ooh, the mean of gender is 0.24. That's completely useless. We just want to know what percent fall in the different categories. We did have some prefer not to answer. Those are missing. And so that information isn't included here. And so it looks like just one person didn't respond. And it should ideally actually show down here in the frequencies, but it is not including that here. So I think what I'm going to do, I'm going to go back to our data and I'm just going to change this. I'm not going to make that missing. I'm going to delete this. I shouldn't have done that. There we go. That way it'll show up. So now if I go back here, now we've got prefer not to say. There we go. So now this information we'll again talk about in class, but we have the count, the number of people who identified as different genders. We have the percent of the total. So 22% were men, 75% women, 1 prefer not to answer. And then we have cumulative percent. This is just adding the rows to each other. So this is 22.2%, and then we add that 75%. So 97.22% were either a man or a woman. That's all it means. Now I need to change some other stuff in here. I do not want a histogram. Histograms are for variables that have numbers, which we do not have. So I want to do a bar plot instead. A bar plot is going to show what the gender differences, what the counts are over here. So we have gender, and then we have man, woman, prefer not to say. And they're separated. They're separate bars because they're separate categories, is one way to think about it. So I'm going to delete this, remove. That's the only graph that we would make for gender. Now, it doesn't have the capability, I think probably because the Jamovi designers know that I personally hate pie graphs, pie charts with all my heart. I'm just kidding. Of course, they don't know, but they're not great. So that's another one you could make, but it's just not something that you're going to do pretty commonly. So this would be for gender. So that's our nominal variable. Now I'm going to save this, go to File, Save As, and I'm going to say gender. I'm going to save. And my next one, I'm going to go back in here and I'm going to edit. Let's do an ordinal variable. So school year, ordinal. And I am going to get the median. I'm not going to get a mean. I can't get a mean for an ordinal variable. There are some people that disagree with that. Part of that issue is that, remember we talked about Likert type scales are technically ordinal. We treat them as continuous in psychology. But I'm gonna, because we only have one question, we're talking about school year, I don't want a mean for that. I just want a median. The mean wouldn't be meaningful. There's no meaningful interval between those different categories. They're just ordered. So I'm gonna get a median. I could get a range, so I could find out the range, but it's a number. I could get IQR, but it's not the interquartile range. It's not super useful. What I would recommend doing is you get your median, and then you can get your mode here. But what we really want, we want this frequency table. So you can see that up here in descriptives, it gives us numbers. The key that's really important here is that it's giving you the number of the level that is the median. So the median 3, it's actually referring to, if we look at our school year variable, 3 equals a junior. So that's what we're actually looking at. It's saying that the median in the mode is junior. So most of the students in the, or the middle student in the class is a median, is a junior. And then the most common year in this class is a junior. And you can see that here. So we actually don't even need this. You could just look at the percentages and figure it out. So you can see that 55.56% were juniors. So that's our mode. And then the median value, that's the lining them up and putting them in order. It's a little bit harder to visualize here. And so this is why it's helpful. It's a quick way you can say, oh, it's the category 3, which is junior. So you would say that the median in mode is junior. And then we don't do a measure of variation except for range. So we can say that students in this class range from freshman to senior. I mean, who cares? That's like, obviously, you range from a freshman to senior. You know, sometimes I might get a grad student in there, but that's a pretty, it's kind of like a no kidding situation, right? And so that's not super helpful. For ordinal variables, I would also do this, the school year as a plot that's a bar plot. This is a bar graph, so I'll leave that checked there. That makes the most sense because they're separate categories, right? So then I will go ahead and I'm going to save as, and this is going to be school year. It's going to save these analyses for me. And then I am going to export this. Export school year. And I'll give you this as an example of an ordinal variable. Now, some other things that I can do. I could actually look to see what the variables are, like how different school years are split up by the condition you were assigned to. So let's say I want to see if I have about equal numbers in each condition. So I just split by condition. So it's just dividing it up by the condition you were in. So there's the birds condition and the opposites condition. And look at that, it actually split you up. It did a good job. It put, there's an equal number of people in the birds and opposites condition. We can see that the median, though, is different. So the median in mode, It looks like there are more juniors, which is level 3, in the birds condition than there are in the opposites condition potentially. So we can look at that and we can compare. So whereas for birds had 0% freshmen, the opposites condition had 5.5% of the group is in the opposites condition that were freshmen. So that's a bigger difference, right? You can see that maybe it didn't do a great job of randomly assigning you to different groups. I'm not going to focus on this today, or well, when we talk about this in class. I'll come back to this when we talk about random assignment to groups. We'll do some examples with this, but I just want to show you that you can do different things like that. You can look by condition. So this allows us to see like, oh, what's the difference in age by condition? What's the difference in whatever by condition? So the last thing that I'm going to do here, I'm going to take this off. The other handout that I'm going to give you, I am going to look at the explanation. So I'm going to say whether or not you found it surprising. That's the variable I'm interested in. I'm going to move school year back over. And again, I don't want a median or a mode. I'll leave this here. So I have a missing value there. I don't know. Ooh, that actually shouldn't be. I shouldn't have a missing. Oh, that's the missing surprising. Sorry, I'm spacing for a minute. So somebody didn't say if it was surprising or not. So we're gonna ignore their response basically. So I want to look at the differences by condition for whether or not people found it surprising. So I'm going to move condition over here. And then I am going to, you can see the plot here. Look at that. People in both conditions said no, it wasn't surprising. So I'll explain what this has to do with hindsight bias in class, but it just allows us to visualize our results. So I'm going to give this to you as another handout. So I will, again, I'm going to export this, save it, and all of that good stuff. One other thing that I'm going to show you, we're not going to do the we're not going to talk about the test in class. You know what? No, I'm not going to get too complicated. Just kidding. I'm changing my mind. I'm just going to show this part. So we'll talk about this in class as well. So you'll get those handouts. And then again, this is just meant to be a video in case you're interested. You wanted to know how I got those numbers. And then starting next week, we'll actually use Jamovi and have you practice in lab. So as always, reach out with questions and I will see you in class soon.